We want to find the slope of the tangent line to the polar curve, r equals 2 minus 4 cosine theta at theta equals pi over 3 radians. Let's begin by determining the point of tangency, and because we have a polar curve, we know the points are going to be in the form of r comma theta, or in our case, theta is equal to pi over 3. So we'll substitute pi over 3 for theta into our equation to determine the first coordinate r. We would have r equals 2 minus 4 times cosine pi over 3. Looking at a reference triangle below, cosine pi over 3 is equal to the ratio of the adjacent side of the hypotenuse, and therefore cosine pi over 3 equals 1/2. So we have r equals 2 minus 4 times 1/2, which is equal to 2 minus 2, which equals 0. So the point of tangency has coordinates 0, comma, pi over 3, which means the point of tangency is at the pole here, and the curve is traced out in this direction here, where at theta equals 0 radians, we'd be at this point. So because the orientation is in this direction, at this point we're looking for the slope of the tangent line in this direction here, or the tangent line with a positive slope. Notice how there's also a tangent line with a negative slope at this point, but we're looking for the slope of this tangent line here. So to find the slope of this tangent line, we'll find dy dx and evaluate this at theta equals pi over 3 radians, where r equals f of theta, which is equal to 2 minus 4 cosine theta, and therefore f prime of theta is equal to, well, we'd have 0, and then negative 4 times the derivative of cosine theta, which equals negative sine theta. So f prime of theta is equal to positive 4 sine theta. And therefore dy dx is going to be equal to this fraction here, where the numerator is f prime of theta times sine theta plus f of theta times cosine theta. So we would have 4 sine theta times sine theta, and then we'd have plus f of theta, which is the quantity 2 minus 4 cosine theta times cosine theta, and the denominator is going to be f prime of theta times cosine theta minus f of theta times sine theta. So we'd have 4 sine theta times cosine theta minus the quantity 2 minus 4 cosine theta times sine theta. Before we evaluate this at theta equals pi over 3, let's simplify this by clearing the parentheses in the numerator and denominator. And let's do this on the next slide. So we'll distribute here as well as here. So we have dy dx is equal to, well, here we have 4 sine squared theta, and then plus 2 times cosine theta, so plus 2 cosine theta. And then we have plus, we'd have negative 4 cosine squared theta, or minus 4 cosine squared theta. In our denominator we have 4 sine theta cosine theta, and then we have minus 2 sine theta, and then we have minus negative 4 cosine theta sine theta, which becomes plus 4. Let's write this as sine theta cosine theta. And notice how our denominator does have 2 like terms here and here. Let's go ahead and combine those. So the numerator is going to stay the same. We could perform a double angle substitution here, but we'll go ahead and leave it in this form. And our denominator is now going to be 8 sine theta cosine theta minus 2 sine theta. And now we'll evaluate our derivative function at theta equals pi over 3. Let's go ahead and do this on the next slide. Looking at a reference triangle here, notice that sine pi over 3 radians is going to be equal to the ratio of the opposite side of the hypotenuse, or square root 3 divided by 2. As we saw before, cosine pi over 3 is equal to 1/2. And therefore dy dx evaluated at theta equals pi over 3 is going to be equal to, the numerator is going to be 4 times sine pi over 3 squared, that'd be square root 3 divided by 2 squared, plus 2 times cosine pi over 3 is equal to 1/2 minus 4 times cosine pi over 3 squared would be 1/2 squared. In our denominator we have 8 times sine pi over 3, that's square root of 3 divided by 2, times cosine pi over 3, that's 1/2. And then we have minus 2 sine pi over 3, which is square root of 3 divided by 2. Notice here when we square root of 3 divided by 2, we'll have a denominator of 4. So this simplifies to square root of 3 squared, or 3. Here we have plus 1. 1/2 squared is 1/4. 4 times 1/4 is 1, so we have minus 1. In our denominator, these two simplify to 1. This simplifies to a 2. So we have 2 square root 3, and then here we have minus square root 3. So simplifying one more time, we have 3 divided by square root 3. Let's go ahead and get a decimal approximation. 3 divided by square root 3 is approximately 1.7321. Again, this is the slope of our tangent line at theta equals pi over 3 radians. And going back to our graph, notice how this does verify we found the slope of the tangent line with a positive slope in this direction here. And because the directions don't say round, we should enter the exact slope as 3 divided by square root 3. I hope you found this helpful.